In this video, we'll take a look at how you can reduce the amount of repetition seen when tiling or repeating textures, so you can go from something like this, where we can see the tiling pattern slightly, to something like this, where it may seem not as noticeable. In addition to that, we'll also take a look at how you can make your own custom node in Unreal using HLSL to splat or place a texture a number of times and randomly rotate, scale, offset, and tint that texture as well. So I have this star texture defined here, and it's placing it, and I can rotate it within a random range, maybe 360 degrees, and then choose how many times I want to place this texture randomly on the surface. So I could do like 5 times, and there we go. So take a look at how we can also create our own custom node to do these types of things in Unreal. So to begin, I'll start with a brand new scene, just a flat plane on the ground here, and I created a new material. I am using substrate, but I'm not using anything substrate specific. So if I open up this material, it will be technically substrate if I add a substrate slab or something, but I'm just using the default Unreal kind of shading without the substrate features that get added. So I can just use this node here, or you can create that by typing substrate UE for default shading. And I'm using Unreal 5.3 in this video, but everything we're doing here can be pretty much used in older versions of Unreal as well. So normally if you have a texture that you're going to put on the ground or something like this concrete I have here, if I add that into my base color or your diffuse color or whatever you want to call it, and you tile it a number of times, I add a texture coordinate and I tile it maybe 4x4 times, you'll notice that you get sometimes this repetition that you start to see because the texture is being repeated, and you start to see these patterns that show up again and again. So one way you can solve that, and this is one way that you can do it very easily in Unreal. Of course, if you have a complex scene, you could use decals that place on puddles and cracks in the ground and all kinds of things to cover that repetition up. But even to help out with that, Unreal does have a node called texture bombing. And this node, if you connect it to your color, or whatever you want to use it for, you can use it for color and normals or anything really. But what it will do is it will take a texture. It'll be a texture object, so I would have to take my texture here and convert it to a texture object. And it will give me an option to tile it, so I could tile it here. Same tiling, 4x4 tiles. And it will tile that texture. And I can't just actually plug in this texture chord. It says S here. It takes a single value. You can see in brackets it takes a default value there. So I don't want to connect it to a texture chords node. I just want to connect it to a constant. Otherwise you're going to end up with problems. So 4 times to tile, 4x4. And now it tiles it, and it looks a little bit different. And you have an offset as well, so I can offset the texture randomly each time it gets placed. So I can offset it by 0.1, and now maybe my tiling doesn't seem as noticeable anymore. So that may help. Now what is this actually doing? Well, I'm going to replace this concrete texture with this little checker XY texture so we could see what it's actually doing. And you can actually see what it's doing is placing the texture again and again, but rotating it and flopping it around each time, and also changing the intensity or opacity that's overlaying on top of itself. So if I set it to be 0 offset and just 4 tiling, you can see how it's being flopped. It's pointing sideways here, then it's overlapping itself with a bit of opacity. So it kind of just flops it around and rotates it, and adds a bit of overlap to make it not as noticeable. And you can adjust that overlap with this offset. So I could do like 1 offset, and now it's really offset. And something else you can also do is add an optional height map to break up the pattern even more. So I can go in here and enable this height lerp with the static bool node and set it to true. And then I can connect an optional height map. So I'll throw in this vertical lines because it'll be very noticeable to see. And I'll convert that to a texture object and use that as my optional height map. And now we'll use that pattern to do like a blend of where you can see it places this Y here, but every second line there, it's placing a different texture or a different offset of the texture. So we can use this as a pattern. And that can be helpful to break things up even more. So if I change this now to be that concrete again, or that asphalt, you kind of don't really see much repetition or tiling. If you go super close, you can probably see those lines a little bit, so you might want to use a more organic pattern, but this can really help make tiled surfaces be more broken up. And you can change the offset value as well. Sometimes certain offset values do give you noticeable repetition. You can't perfectly fix it, but you can help reduce the look of tiling. So this is fairly useful to use when you run into those issues. It can also be used for other things as well. You can get creative with it. You can also add like time to the offset as well. This is something that's kind of interesting. If I go back to this X and Y checker, a lot of people don't realize that I could take this offset, connect it to a sine node, connect that to a time value, and get, I'll turn off this blending. There we go, offset, time, and if I put this in my scene, just going to minimize this, you can get a very interesting pattern of almost like different layers being offset and moved. So it can be useful for some effects, possibly certain effects, but that's more up to you. It's more up to whatever you need creatively to achieve the look that you're wanting to. So just something interesting that you can do. Now, to take this the next step further, this node doesn't really give us much options here. If I go back to this texture bombing node, we have a couple options here, but we don't really have that much control. I can't control how much it rotates this texture by. I can't control the scale of it each time it places that texture, so you're kind of limited in certain ways. So we're going to take a look at how we can write our own node in HLSL and do a similar thing to this, like texture splatting or texture bombing, but we'll have more control to be able to tint each time it places the texture, to give it some random scale, random rotation, random offset, and just have a lot more control over what it's doing. So to start with creating our own custom node, I'm just going to first create a brand new material. I'm going to call it m underscore texture splatting. And I'll open this up, material editor. And what we're going to start off with is a custom node. I'm going to maybe rename it to custom texture splatting, whatever I want to call it. And I'll connect that to our base color just as a test. And right now it's not doing anything, so we're going to have to add some code to it here. But before we do that, there's a couple things that we know that we're going to need. We're going to need access to the UVs. We're also going to need access to a texture that we're going to provide for this node for it to place and rotate and scale and do whatever it's doing. So we're going to make two inputs for this. We're going to make a UV input, and we're also going to make another input called input texture or input text. And there we go. And once we've done that, now we can start jumping into a bit of code since we have the very basics of this defined. So I'm just going to open up Visual Studio Code and use that to type my code in so it's a little bit easier to see than that tiny little window. And what we're going to start off with is just blocking in our shader, blocking in our HLSL shader. So I'm going to start off with a float 4. So that would be red, green, blue, alpha, 4 values called result. And here it is, float 4, red, green, blue, alpha. Alpha could be 0 or 1, doesn't matter at this point. And that's it. And then what we're going to do is start defining other things we'll need that we know we're going to need. So we're going to also have to define how many times it's going to place this texture that we're going to provide. So let's add a variable for that. I'm going to do a float single value called splats, and maybe just make it 3 by default. It'll place the texture 3 times on the UV space around the surface. So we'll start off with that. Now I'm going to block in the rest of the code. To place that texture, it's going to have to do a loop. It's going to have to place it and then repeat it, place it again, repeat a loop again, replace it again. So I'm going to do a for loop for placing these textures. So I'm going to do a for and then say like int I, define a variable, make it equal 0. If I is less than that number of splats that we defined, 3, then I++, and it will do whatever's in this set of brackets again. So that's our loop, and this will be how many times we go through that loop. And at the very end, we're going to return the result, but we need to write into the result. We've defined it here. We return it at the end, but inside our loop, we'll have to write that texture that we're placing into it. So we should have something like result plus equals. So it adds to the result each time it goes through this loop. And we'll call it sampled color because we'll be taking a texture and sampling from it. And we'll define that as well. So we'll do a float for sampled color. That's our texture that we're going to be plugging in. So we have to load a texture 2D sample. So texture 2D sample, and what did we call it? We called it input text. Yeah, input text. So input text, and then input text sampler. And then our UV space, of course, our UV's there. And that's it. So that's kind of our base structure for this shader code. And at this point, I'm going to copy that, place that in here into my custom node, and just make sure that works before we go any further. Let's get this connected up. We'll put a texture coordinates node there. And we'll put our texture into here. And what are we going to use? I'm just going to use these vertical bands for now as an example. Convert that to a texture object, place it in there. Hey, look at that, it works. So we got something working. Great, now we need to do all the work of placing that texture more times. It's placing it right now on top of itself, but it's not doing any random rotation or scale or anything. So we have to start adding that in. So we don't need to overcomplicate this. I'm going to go back into our code here. What other things can we add to this that we know we're going to need? Well, we're going to need a random scale within a range. So I'll define a float 2. I'll call it scale range, and I'll give it a range. So I'll give it a range between maybe 1 and 3 for scaling its original size, or up to 3 times bigger than it was, or 3 times more tiled than it was. And then we'll do another float 2. Float 2 because the first range is the minimum, the second value is the maximum. And we'll call it rotation range. So what's our minimum rotation going to be? Well, maybe it's 0 degrees, and our maximum rotation will be 360 degrees. Now, what else can we do? Well, now that we have those ranges defined, how can we go about adding those things into our loop to manipulate that texture when it places it? Well, we want it to be random as well. So we have to kind of create a random number, or just some sort of number that's going to change constantly every time it goes through this loop. So to do that, I'm just going to make a seed value. So I'll define one more thing up here, float 2, called seed, and I'll make it have it could be really any number. All we're looking for is getting some randomly changing numbers every time it runs through that loop. So I'll just do 1, 2, 3, dot 4, 5, 6, and then 7, 8, 9, dot 10, 11, 12, or 0, 1, 2. Sometimes I do those numbers backwards. Sometimes I just type in random numbers. It doesn't really matter too much. It's not going to really affect the outcome that much. It'll give you a random outcome that's slightly different, but there's no specific to what you're doing there. You're just trying to add in some random numbers. So after doing that, I'm going to use that seed as a way of changing our offset value, changing our rotation values every single time it places this text here. And we're doing this a really cheap way. And the way we're going to do that is take that seed value and we're going to make it equal frac seed times, and again, 1, 2, 3, 4, 5, 6, or something like that. And now each time it iterates through here, it's going to make seed equal frac seed times 1, 2, 3.456, and they'll just totally give it some new value each time it runs through this loop. So now how can we use that seed value within something like our random scale or random rotate? Well, I can do my random scale here. So I'm going to define a new variable called float random scale, or rand scale, and I'll make it equal a lerp, a blend between one value and another value based on a mask. And those values will be scale range X, so the first value of our scale range is the minimum scale and the maximum scale. So X is going to be this number, Y will be that next number. So it will choose a random range between our minimum and our maximum scale range Y based on our seed value. Here we have 2, X and Y. When we do this, seed equals frac seed, it's dealing with those two values. So we can just use something like seed value X. And that way, every time it runs through this loop, it will choose a value between the minimum here and the maximum of our scale range. And to blend between that minimum and maximum, or to choose a value in between that range, it'll be using a mask, which will just be a completely new and different value each time this runs through from our randomization on the seed number here. It's not really randomization, but it's just changing due to this multiplication of random numbers each time it runs through this loop. So that's a very cheap way we can generate like a fake random number. It's not truly random, but it will appear random enough for what we're having to do. And that's really the bulk of the work. And now we just do the exact same thing for rotate. So float random rotation equals, now this time it's going to be the same thing, but we're defining our rotation in degrees. But we'll have to make it radians for when we're doing our loop here and placing the text here. So I'll convert the result to radians, then do my blend, my lerp, and do my rotation range.x, rotation range.y, and then our seed y we'll use. So it's slightly different. It's not going to use the same one as the other one. And there we go. So now we have our random scale, our random rotation values. How do we use those to actually scale and rotate our texture that we're placing, our sampled color here, our sampled texture? Well, first we have to do, well, we've done this before. We have to set up our rotation. So to do this, we're just going to create a float 2x2, like a pretty much a rotation matrix, I'll call it. And we'll do cosine, rand rotation, and then negative sine, rand rotation, and then on the next line, sine, there we go, sine, random rotation, and then finally cosine, random rotation. We've done this before, so if you're not sure kind of why we're doing this, you can watch the video previously to this, and we go over this and how this is actually going to rotate it clockwise, but you can also change this negative and flop these and also make it rotate counterclockwise. But this will pretty much just reorient the numbers of the UVs to rotate this texture based on the amount that we have in here. Now that we have all that set up, that gives us our rotation value that we can use. And then scale is just super easy. We just multiply it. So we'll create another variable here called float to UV result, and I'll make that, I have to multiply, so I'm using multiply, and I'm going to multiply my rotation matrix by our UVs, and that would rotate our UVs, but I also need to scale the UV, so I'll do UV multiplied by our random scale, so that will scale the UV, and then it's going to rotate that scaled UV with our rotation here. And then, now that we have that UV result, we can technically use that here instead of just using the unaltered UV. This is our new altered UV where it's rotating it, scaling it, so it's placing the texture differently on that UV space. So we'll use UV result. And we'll test this out. So I'll copy this, throw this into our Unreal code here. What do we get? We got some errors, return a result. Okay, let's just go back to the code for a second and tie up these loose ends. So it gives me a little bit of an error on the result here. And the reason for that is we're taking a result, we're giving it that sampled color. Let's see what the error is. Too many elements. Okay. So I made some very basic mistakes here. I'm defining two values here. I put float2 here. I didn't put the float2 there. There we go. So that's gonna solve that error. So I'll copy that, paste that back in here. Okay, there we go. And look at our result. It's definitely rotating those lines and placing them differently. Now the problem is if we add a lot of these splats or placements of this texture, it's going to get brighter and brighter and brighter. Now we might not see it too much here, but the reason why it's going to get brighter, brighter, and brighter is because we're just taking the result and we're adding that color again and again and again. And each time it overlaps itself, if it's a value of 1 and you're plussing another value of 1, it becomes 2, 3, 4, and it's becoming brighter and brighter each time. We might not want that. It might make things look overly bright. So one thing we can also do at the very end here to deal with that is take the result, or before we output the result, make it equal. So we can take our result here and make it equal, or divide by the number of splats. That way what it's going to do is every time it runs this, it's running it 3 times right now, placing 3 textures, they'll get plussed on top of each other and accumulate, and at the very end we'll divide it by 3 so that the highest value ends up being 1, or so it doesn't end up being stacked too bright. So that can kind of be almost like a brightness control. And then if we want to adjust contrast, there's many ways you can do this. We can also do something like result equals pow, and that's power, so we can times this result by itself. So we'll take the result, our resulting image, and times it by itself a number of times to increase its intensity as like a contrast control. And that number of times, I'll just use a variable that we'll define called contrast, like that. And if we do that, and copy this over here and paste it, add that new variable called contrast, make sure I define it just as 1 at first. That's what we get. You know, not as bright because now it's dividing, so areas that would have maybe got blown out or become brighter than 1 are now being kind of clamped down. And if we want, we can adjust the contrast. Like I said, this to 2. It'll multiply by itself, get brighter and darker in areas. So we have a contrast control now. So now we have a contrast control, and we're not getting overly bright values. And we have something that kind of works. You know, I can place this texture maybe 8 times, and it's placing 8 times, overlapping itself, and we get this interesting pattern. So already this is pretty cool. Now, how can we take this a step further? Well, I'm going to change this image here to maybe that star texture now. That's actually kind of cool what it's doing. But one thing you'll notice is if we set the amount to be like, and this would be a bit excessive, but maybe 50 times its placing, we start to see a little bit of a pattern here where the star is being placed. Right now we're scaling it. What happens if we don't scale it? We just leave it at the default scale, 1 and 1. Creates like a circle. So it might be nice right now is giving the illusion of the star being offset because we're tiling it differently each time it gets placed. But if the star stays the same size, we could see that it's kind of getting placed at the same spot. It's rotating, but getting placed at the same spot. So maybe we want that to offset a bit. So how can we introduce that? And how can we tint these stars to be a different color each time they get placed? That might be a cool feature. So how can we add that stuff in here? Well, what we're going to do is go back to the code and is take a look at what are we wanting to add here. We're wanting to add custom color tinting, and we're wanting to also add a random offset. So let's add that random offset first. So we're going to go up here and define a new float2 called offset range. Make that equal float2, define a range, maybe -1 and +1, and that's it. And then we'll work that into here. So how can we add an offset? Well, first we need to give it a random each time it runs through here. So we'll do float2 random offset, float2 because it's offset in X and Y, the two values we defined. So we're going to do random offset in both directions, so float2. It'll equal the same value, but that's okay for now. We're just going to make them lerp offset range dot x, offset range dot y, so it'll make each of these just a range between -1 and 1. And then we'll use our seed as our random value, and you can see I'm not defining seed x or seed y, just seed because it's float2. So we're treating x and y separately. So it's going to blend from -1 to 1 and produce two numbers, and one of those is going to use this seed value, the other one's going to use this seed value. Of course it runs through here first to randomize it even more, give it a different value, but that's what it will be using. So that's kind of why we're not defining x and y, because we've defined a float2 here. It's going to produce two numbers. And how do we add this offset into our texture? Well, on our UV result down here, we keep everything the same. We're going to put this UV multiplied by its scale inside a bracket, and we're just going to add that random offset at the very end. So we'll just nudge that UV at its current scale off a bit and then rotate it. So that should work. And you could customize this totally and probably make it a lot better, but this will work for now. Now, final thing, how do we tint our color? Well, easy to tint something that's grayscale or black and white. You just need to multiply it. So I'm going to take our sample color, our result, sampled color here that we end up writing out to our result or adding on to our result, and I'm going to tint it. So I'm going to multiply it and equal, so that multiplies it and assigns it to a new value. And we're going to define a list of tints, or kind of like I guess our array of tint values. So we're going to do something like float4, and we're going to call it palette. And I'll give 3 values for now. I'll just make them really simple. Float4 red, and setting the alpha to 1 so it's not see-through. Red, green, and blue. So let's change these. So red, green, and blue. There we go. And that's it. So now I can use this here, this like array, and I can make it every time it runs through this loop, it'll take the resulting placed star texture, or whatever texture that is, and multiply and equal, so multiply and assign it this color. So what would that color be? It's going to have to be one of these randomly. Now how do we do that? We can use that palette if we do something like this, we're going to run into a problem. We could use the I amount here, the amount of times it's running through this loop, but this is only 3 values. So when it gets to run the loop the 4th time, it's going to be an out of range index, which we don't want. It'll be out of range because there's only 3 things here, but you might be splatting the texture more than 3 times if you splat it like 6 times or 10 times or something. So that would produce maybe a little bit of a problem. So what we'll do instead is we'll do I plus 1, so it's offsetting it every time, and then modulus 3. So doing something modulus by any number just divides it by that number and outputs 1 or 0 if there's a remainder or not. This way, what we're going to be doing is adding 1 each time, so we'll end up just looping through here like 2, 3, 1, or 3, 1, 2, or whatever. It'll just loop through all these values again and again. So that will work. And you could change this up if you want different types of randomizations, but I'm just going to do that because I'll keep it simple. And maybe at the very end, we want also a control over the brightness of the result. I kind of have that here where it's dividing by the number of times it's splatting or placing the texture. But if I want a bit more control over that, maybe what I'll do is divide it by brightness, and I'll make a value in our custom node for brightness, and that'll just give us a little bit more control over the result. So we'll take all this, hopefully there's no errors, paste it in here, see what we got. We got errors. We do have errors in brightness because I need to create that variable, so I'll add it here and call it brightness, and I'll define it as a constant, just 1 for now. Okay, so there's our stars. Now if we tile them a ton of times, like 50, yay, they're not in that weird circular line anymore. And they're scaling, so let's turn off that scaling, just keep it the same. There we go, they're not producing that circle anymore. And this looks too dark, so maybe we want to up our brightness. We got our brightness here, let's up that to like 5. Alright, now the stars are brighter. Want more contrast? Put our contrast to 5. Alright, now it's more contrasty. So maybe the scale's too big. We go in here, we scale everything maybe twice or 5 times, just a random. Oh, there we go. We got tons of stars now all placed. So really cool. We can make this node super flexible, super useful, quite easy to make. And you could extend this way further. You could use this to even have animations. You know, you could use some of the things we've done in our previous videos using sign and time and other things to make these move a certain way. But it's a pretty robust and flexible node now that you can reuse, you can modify, and you know, you can choose how many times you want to place this texture. 3 times, 5 times, probably don't want to do this, but 250 times. There we go. So try it out, see what you can create, and if you like this video or you learned something new, don't forget to like, subscribe, and check out the Patreon in the description below to get access to this PDF that goes over all these steps that we covered in a little bit more detail as well. And you'll also get access to the HLSL code as well if you're part of the Patreon. So check that out if you're interested and see what you can create.